Yeah, we will do another example. It'll be similar but not the same, but it will be still very useful to you. It'll actually, it's pretty similar to the last one, but the fraction subtraction is a little more difficult, so we will spend a little more time on that part. So we've got two fractions now, and we're going to go through the same process. I'm going to subtract everything to a side, simplify this out, plot where it's 0, pick points between, and go from there. So I'm going to subtract this over to this side. And then because I'm doing subtraction of fractions, a over b minus c over d equals ad minus bc over bd. Remember, I have to do the cross multiplying thing. That thing there. So this times this, x plus 2 times x minus 2. This times that, so minus x minus 1 times x plus 3, all over x plus 3 times x minus 2. And this is all gross, admittedly. But we can do some processing here to figure some things out and make it not as gross, but it's still going to be pretty gross, so I apologize. Alright, so just foiling everything out, I've got x squared minus 4, because this is a difference of squares here, so I don't really need to do any math. It's just a plus b, a minus b, a squared minus b squared, so x squared minus 4, minus x squared, so I'll put it in parentheses and the minus will distribute through, x squared, 3x minus x is 2x, negative 1 times 3 is negative 3. I'm going to leave my denominator as is. I'm going to further simplify this, so this is still greater than 0. That's x squared minus 4 minus x squared minus 2x plus 3. So all I did was distribute this minus sign into these parentheses here. I'm still not touching the bottom. X plus 3 and x minus 2 greater than 0. And then further simplify out the top. So negative 4 plus 3 is negative 1. These x squareds cancel. So I'm left with 2x minus 1 over and x plus 3, x minus 2 greater than 0. Just making sure everything is good there. Yes, I copied everything. Okay. So all I've done is I've done this subtraction here. It's gross. It took, what, 1, 2, 3, 4. It took 5 lines, but we got there. So I cross multiplied, foiled out everything on the top, and then simplified the top. All right.
I have a question.
Yes.
How do you know what goes on the top after like you cross multiply?
It's always this times this, and then this times this.
Okay.
And then the bottom is this times this.
Oh, okay.
Always that. This cross multiply here. So now I'm going to go to where this is 0, the numerator or the denominator are 0 on my number line. 2x minus 1 is 0 at x equals 1/2. This will give me a negative 3. This will give me a positive 2. Got infinity over here minus infinity over here. And then I just figure out what is in those certain intervals, what it's doing in those intervals. I'm going to specify above where the bottom is 0 that this is undefined, because I can't divide by 0. And at the 1/2 is 0. All right. What's a number that's less than -3?
Negative 4.
-4. What's a number between -3 and 1/2?
Negative 1. Negative 2.
Let's pick 0. That'll make it easier. What's between 1/2 and 2?
1.
1. And what's above 2?
3.
Beautiful. Now I'm going to go through and plug all these things in. I'm going to try to do this in a little less space. Plugging in -4, I get, where's an eraser? Plugging in -4 to that, I get -8 minus 1, so -9. -4 plus 3 is -1. -4 minus 2 is -6. That's +6. So this is negative. I'm just doing this in less space because this is something that you go through and work out pretty well. I'm just plugging this value into this here. 0 into this, -1 over -6 is +1/6. 1 into this, 2 minus 1 is 1. 4 times -1 is -4. So I get a minus. And 3, that's 6 minus 1 is 5. 6, 1, 6. So plus. Almost always when you do these, you're going to alternate between pluses and minuses because we're dealing more or less with polynomials and the rationality or rational functions of polynomials. All right. So we've got our little bit of info here, and now we want to figure out where is this going to be strictly greater than 0. So I look where it's positive. I've got some positive here, and I've got some positive here. Do I include -3 and 1/2? No. It's for different reasons though. Why can't I include -3? Undefined. If I put a -3 here, the bottom would be 0, and I can't divide by 0. Why do I not include 0? Or I mean 1/2.
Not equal
There's not an equal to sign here. There's a greater than, but not greater than or equal to. So I have to clarify that. So from -3 to 1/2, not including either of those. And then I also have this up here. Do I include the 2? Why? Undefined. Union 2 off to infinity. And I never include infinity. And that's how you'd find the answer for something like this. That's a union between those, so it's both of those together. I'll write it out as one so you see it. So that's how you would go through and find the interval solution for something like that. Your first instinct might be to just divide this over. But I can't do that because I don't know if this is positive or negative. So I don't know if dividing it over is going to change my sign or not. That's why I'm always going to have a 0 over here, because I need to subtract it over rather than dividing. There's the answer to your question. I have to subtract it because I don't know if I'm going to flip the sign. If I were to divide by it, I would be left with a 1 on this side, but an unknown sign in between them. Yes?
Where'd the 1/2 come from?
I picked 1/2 is where the top equals 0. So my points that I list here are always going to be where the top equals 0, where the bottom equals 0. Those are what we call critical points. So the points that I'm putting boxes around are what we call critical points. Critical points are wherever the function is equal to 0 or it's undefined.
What made the numerator actually mean something this time as compared to the last one? Is it just
It has
the-
x in it.
Okay.
Because it has a variable in it, I can't say that this is always positive or always negative.
I see.
I can plug a number in here where this is negative, or a number in there to where it's positive. Plugging -4 makes it negative, but plugging in +4 makes it positive. The last time we were dealing with just a number which can't change. It's a very, very good point there, though. That is a distinction that you have to make. If there's a variable here, I have to actually do something. Otherwise, if it's just a number, I'm just checking where the denominator is positive or negative. But this isn't just a number. There's a variable there. Any other questions? Yes?
Why did the sign, like, from the bottom to the top, why did it, because it went from less than to greater?
Because I whoopsied. No one else pointed it out. I didn't mean to change that. I just accidentally copied it down wrong. Less than, less than, less than. So we're gonna pick all the other intervals. Instead of doing that and changing all these intervals, I'm gonna keep these as greater than, and I'm gonna change the other side of the board. And our answer's correct. Now we're doing math like a physicist. If your answer's wrong, your answer's not wrong, you just asked the wrong question. They do that in physics all the time, and it's really funny. That's like the entire story of where dark matter comes from. Is our equations didn't add up in physics, and so we just added dark matter, which we don't actually know what it is. And now our equations make sense and our answers are right. It's a little more technical than that, but at a very low level, that is exactly what happened. Any other questions? Thank you for pointing that out, Anne. Any other questions?
No.
I'm going to erase this little bit right here. I'm going to leave the rest of that on the board. I have just one more thing to show you, and then we will call it a day and finish out the material for the test tomorrow. Cool? All right. What if I have an absolute value? We've dealt with just about any other thing, but I want to wonder, what if I have the absolute value of x less than a? The solution to this, and you'll probably just have to learn it from your notes instead of actually reasoning with it, is that this is the same thing as saying x is less than a and greater than negative a. That's all I can really say there, but that's still pretty useful. If I'm taking the absolute value of a function, it's in between those. So for instance, I'm going to draw out what the absolute value function looks like. It looks like this. And I'm saying this absolute value function is less than, say, 3. That's the same thing as saying, so here's the line where x equals, or y equals 3. And I'm saying x less than 3 greater than negative 3, which is true. Wherever this is, because this is just a slope of 1, this is just a slope of 1, so the point here is 3, 3, negative 3, 3. But that's why it's like this. Specifically because it does all of this stuff. When I have a regular function that's linear, for instance x, this is not true because it keeps going on forever down this way. But absolute value flips all this negative stuff up. And so that's why it looks like this V shape. And it's everything below that line, so it's this chunk right here. It is a specified region. But more or less, just write in your notes that if I get something like this, I can remove the absolute value sign and put negative the upper bound here. This works not only for absolute value of x, but absolute value of any function. So for instance, if I had something like that, this is the same thing as saying x plus 5 over 2 is bounded between 4 and negative 4. And then I can solve it like normal. Multiply everything by 2. That's not a square, that's a times 2. I'll put it there. I get negative 8 less than x plus 5 less than 8. And then subtract off the 5s. Negative 13 less than x less than 3. So that's how you deal with an absolute value within that. You'll see this in homework 2 and then again in review homework 1. Homework 2 I believe is due the 1st, so that's Tuesday. So you'll have a couple days to do it. Homework 2 includes everything after complex numbers. So we did complex numbers last week at some point. So it's everything after that is homework 2. Any questions about this?
No. Is that our answer?
Yes, this is the answer. Any questions about anything?
Well, that's a new problem.
Yes, this was a new problem. All right. That's all I have for y'all today. If you have questions, office hours, emails, anything like that, and have a great rest of y'all's day.